What's up guys, it's Devin here, back again with another video, and today we are talking Linux yet again. So stay tuned, this time we're getting to something a little bit nerdier. We're talking about packages and package managers. So these days there is a plethora of software available for Linux. As a developer, I don't really have any issue finding any software that I need to get my day-to-day done using pretty much any Linux distribution out there. However, there are some proprietary software like Adobe stuff that, we're not going to get on Linux probably anytime soon. But for the most part, whether it's a proprietary software that's packaged for Linux or an open source alternative, you can usually get what you need done on Linux, whether you're the average Joe doing web browsing, email, stuff like that, or someone doing a little bit of development. Even some gaming has gotten a little bit better. That being said, it can be a bit difficult for a developer to figure out the best way to distribute their software on Linux so that the most people can get access to it, can get a lot of reliable and quick updates in similar ways that people are used to distributing software on Windows, on Mac OS, maybe even on mobile platforms like iOS and Android. Traditionally, software has been distributed on Linux through package repositories. So most Linux distributions, basically any modern one, has a package manager that downloads the software that you are needing, as well as all the dependencies such as shared libraries and things like that that may be required by the software. Now, these repositories are owned and managed by the distributions themselves. So all the software that you download from apt-get on Ubuntu is all maintained by an Ubuntu developer or Ubuntu maintainer somewhere. So it's a lot of manual labor on the Ubuntu side as well as manual labor on the developer side to get it to Ubuntu and have Ubuntu approve the software, test it, and get it distributed. So it takes a lot of control out of the actual developer's hands, which, understandably so, can be a pretty big turnoff to developers, especially in this day and age of app stores and distributing software. On top of that, if you manage to get your software into the Ubuntu repositories or something like that, you then have to worry about all the other distributions out there. We have Fedora, we have Red Hat, we have Arch Linux, so many other distributions that all have their own repositories, and they don't just automatically upload what the others have. These are distribution channels that you have to go out of your way to go through, and while you can stick with something like Ubuntu that is one of the more popular desktop distributions out there, you're still not going to get the full coverage. People are going to have to go way out of your way to be able to compile the software for their own distribution if you don't provide it, and if you're running some proprietary software, then that may not actually be a good alternative at all. Sometimes you can get proprietary software to run on other distributions, sometimes it's not so easy. On top of that, the way that package managers work with Linux, applications don't just package in all of their dependencies in libraries that they need for it. In fact, it's a very clever design, although a bit outdated in some ways. Applications actually share libraries between each other. So say you're developing an application and there is a public library available to accomplish some task. So instead of writing that entire software bit yourself, you could use this library, get it already tested, pre-made, and ready to go for you. But with Linux, you're kind of actually using the same library that other packages are using. So that way you reduce kind of doubling up on packaging the same library with two different applications. If that library has some kind of a security vulnerability and gets updated, that all the packages that use that get that benefit without having to update and then distribute them over again. So it has a lot of really, really good benefits. However, this means that application developers also need to kind of stay on top of these things. You can't just release an application on Linux, let it sit there for a few years, and expect it to run flawlessly. Some packages make it updated where they have breaking changes that, the software that uses those packages have to be updated as well. Some things may not be intended to be breaking changes, but cause issues anyway. If these developers aren't on top of it, aren't communicating with the distributions, and even if the distributions themselves aren't staying on top of actually this feedback loop, it can cause a lot of problems. And traditionally, things have worked out very well. I've never really had many issues running Ubuntu and the software on it, but they also have a method of keeping back packages for a while and not upgrading to new major versions that are likely to cause breaking changes, whereas distributions like Arch try to run the latest of everything, the latest libraries, the latest packages. In my experience, that has caused some issues. It may not be very widespread, but when a library gets updated that has breaking changes in your software, whether it's some development tool, even just your web browser, if that breaks, as an end user, you're fairly frustrated. Sure, you get the benefits of the new features in the library, maybe some security vulnerabilities that have been patched, but I think most people would take working software over those things in most situations. So how do Windows and macOS handle this? This obviously isn't really a big problem to them, but they do things quite a bit differently. So shared libraries, shared packages are actually kind of a thing in these applications, but they aren't exactly shared across the operating system. So a developer can take some Windows library out there, pull it into their project, and use this pre-made code to their liking, but that is not installed onto Windows itself in the same manner that it is on Linux. That library is going to be packaged with every Windows application that uses it, which means you are going to potentially waste a bit of space on your hard drive. However, hard disk space is pretty cheap these days, so it's not nearly as big of a concern as it used to be. And also, if the application developers don't update those libraries, especially with something where you have a security vulnerability being patched, then the user is going to be exposed until a developer actually does their due diligence. So it's got its ups and downs, but the biggest thing is that when these applications, libraries get updated, because the developer has to actually go in and update them themselves, you don't really have these breaking changes. You don't have applications that are suddenly breaking out of nowhere because of an operating system update, and things pretty much work smoothly until the developer actually makes a mistake. There have been several solutions proposed across the Linux ecosystem to handle this in various different ways that are cross-platform or cross-distributions. One of those that I have experience with is AppImage. One of my favorite applications that actually bundles their application with AppImage technology is Etcher. Etcher is a very simple Electron-based utility that allows you to write Linux ISOs to flash drives very, very, very easily. If you ever need to do this, it's an incredible piece of software. In fact, it's available on Windows, macOS, and Linux at etcher.io. But the Linux distribution that they deliver is actually an AppImage. They do have an Ubuntu repository available if you want to go that more traditional route, but if you just go and download the application straight from the web page, you're going to get an AppImage file. Essentially, this AppImage file contains the packages to run the software and all the libraries and everything that it depends on, and you basically double-click that application and it loads straight out of a container. This is something that you might see more along the lines of with Windows or macOS, something that's a little bit more user-friendly, a little bit outside of the norm of Linux, but it works, and it works very well. I didn't have to install any other piece of software on my computer. I was able to just download this etcher.io, or this Etcher software from etcher.io, double-click, and run it as I needed to. And it was really nice. However, that does have some downsides. It's a completely self-contained piece of software that actually is built around container technology. However, it doesn't really have a repository associated with it. So you're not going to get the same level of app updates, and with as many pros it kind of has some cons along with it too. Another packaging solution that's out there is called Flatpak, that's been around for a little while. So Flatpak is very similar to AppImage, and it's got some pros and cons. I'm not going to go through every single detail, but it does have the benefit of being able to work independently or be associated with a repository, so you can download updates directly from a repo and not have to go to a web page and manually download anything, which is really nice. That being said, Canonical, the company behind Ubuntu, has their own proposed solution. In the past, Canonical has kind of tried to reinvent the wheel several times over in ways that I didn't necessarily seem worth it. So when they announced Snaps, I was a little bit hesitant. I was kind of taking a back seat. I wasn't diving in all the way, but I was watching. And to my surprise, it's gone really well. It seems like all the major distributions are on board, so we have Fedora, Red Hat, Arch Linux, all the main distributions, Elementary OS, tons and tons of different distributions that are all, if they don't bundle the Snap software built into the operating system, they make it available in their repositories. The Snap software is basically a hybrid between these containerized applications that have all the libraries that they need and all the software and dependencies that they need bundled in, as well as a user-uploaded repository so that you can get automatic updates and any user essentially can actually upload a snap to the Snap Store, so we've seen a lot of software come out. When Canonical doesn't have to be the gatekeepers to all the software and to maintain all these packages, we see a lot more movement, a lot quicker, and a lot of companies are taking notice of this. So while Snap packages might be reinventing the wheel in some kind of a way, they are a newer approach that I have liked a lot. It's a very clean experience, and it's catching on quickly with a lot of big companies, and adoption is extremely important when it comes to package managers. So where did this all come from? Basically, Snap packages originated from Ubuntu Touch, actually. So Canonical wanted a way of being able to distribute packages that you could bundle in all of the libraries and dependencies into that package so it did not affect the system whatsoever, making it a very stable and user-friendly experience. So the system could be updated on its own, all those packages, all those libraries could be updated at once, and the applications could be updated completely independently in their own container, making it so that applications in the OS could be upgraded by itself without having to worry about breaking each other or interfering with each other in any shape or form. So while this was designed for mobile initially, the Canonical developers took a step back and said, alright, we've got this really clean packaging format in a sandbox environment that's pretty secure, all things considered. It's less risky for the users, and puts more ownership into the hands of developers and less maintenance for us. All things considered, it seems like mostly a win situation. There are some downside. Like we said, there is a lot of onus on the developers to keep up with their applications, to keep them secure and keep them up to date, but that's the world we live in these days. With app stores and all that stuff, developers have their responsibility, and I think overall that's how it should be. We should not burden distribution maintainers from doing all this work, all of this testing, and all this distribution. It's just simply too much, and it doesn't scale. So what are some of the real big pros with using Snap packages over your typical package manager? Well, there's a few things. First of all, your package is most likely to be up to date as far as the actual user application goes. There's a bit of red tape that goes into getting a new update to a package into the Ubuntu repos because there's a lot of testing involved, there's compatibility with the libraries, a lot of stuff to look over, so sometimes these packages don't get in there quick enough, and it's actually had some negative side effects. One that I can speak to specifically is that OwnCloud didn't get updated for a long time, and it may actually still be out to date to a point where the software had a major security vulnerability, and Canonical just, for whatever reason, whether it was priority or just, having a lot of other software that it needed to attend to, but the updates for this didn't get pushed to it, and so the OwnCloud developers ended up going their own way and really recommending that people download it themselves from the OwnCloud website, so that's where you can see where this kind of has a downside. However, with the Snap Store, users can upload their own software, OwnCloud, Nextcloud, whoever can actually upload their software themselves, upload the updates, and push it directly to users. And with the way that Snap works, it runs in the background and it will auto-update your applications so that you're always up to date and you don't really have to think about it much, which is really awesome in my opinion. Snap packages also are in a sandboxed, containerized environment, which means there is a few more security benefits to this. So as a user, you should really know and vet the software that you use to ensure that it's not doing anything malicious. But in the case of Snap packages, even if a software attempted to do something malicious, by default it's a very sandboxed environment that it can't break out of, which by default gives the user some more security, some more peace of mind as well. I know it does for me, and it's something that I really appreciate. And the last big benefit, in my opinion, is the fact that these are updated independently from the OS. So as you go through major updates from Ubuntu 18.04 to maybe Ubuntu 18.10 or Ubuntu 19.04, maybe even the next LTS, you can rest assured that your Snap packages that you're using are going to work across all of these distributions because of just the nature they are. They bundle in everything that they need to run, so no matter what version the OS is running, they'll run on top of it as long as Snapd is supported in the operating system, which of course it is on Ubuntu, and going forward to Fedora, Arch, and all the other major distributions as well have this. So you don't need to worry. This makes operating system upgrades much easier. You may be much more likely to upgrade your operating system, which is going to make you more secure, and you're going to be running more secure applications on top of this that are less likely to break. So what are some of the cons? This all sounds great, but there has to be some downsides, right? Well, there are a couple. So first of all, snaps are pretty reliant on a repository. Typically you download a snap from a repository and you get updates from a repository, so it's a little bit more reliant on a third-party resource than something like AppImage, where everything is bundled in, there's not really any repositories, and developers are, put to the task of distributing the software themselves. So depending on, how you feel about this and how you feel about auto-updating, which I believe can be turned off, it may affect your decision on which route you go, because a lot of this software is actually available on multiple of these packaging formats now. So you may have the choice of getting it through a snap, through a Flatpak, or an AppImage. Another con is, in general, if you use snap packages, you're probably going to be taking up more space on your hard drive than if you would using the regular package manager. Like I mentioned previously, libraries are all bundled in these applications, so you may have multiple versions of the same exact library sitting in two different applications taking up space when they could be sharing the same thing. This was a major benefit of package managers with Linux, from the beginning, and it's kind of interesting that we're backtracking on it a bit, but I see the benefits. I see how these shared libraries can work very well on an operating system level, but I can see how they benefit more, or benefit less rather, on an actual user application level, and I think that the onus of the developer to manage those libraries and the benefit of having stable software outweighs the downside of not having to have multiple copies of the same shared library across your system. That being said, disk is cheap these days, and I don't think it's going to be that much of an issue for most people. It should be very, very minimal overall to have multiple copies of these libraries, because typically they're pretty small anyway. Like I've also mentioned, developers are responsible for updating the software, so if they don't do it, then you're kind of out of luck, where you might get lucky before and a shared library gets updated and everyone benefits just automatically. So if you have a developer that's not updating their software very much, maybe they're way behind on their software library stack, or maybe they just abandoned the project, you may be at risk in certain ways. Hopefully, the sandbox nature of these applications helps mitigate that, but we can't always be for sure depending on the nature of the actual exploit or attack. Finally, there is one more downside. Because snaps are user uploaded, basically anyone can go upload to the snap store. We've had a couple crypto miners that have come out. They've been addressed very quickly by Canonical when they've been found, but it's possible. Anytime you have a user uploaded repository, you can get some malicious stuff. But again, these are crypto miners, these are not doing anything or breaking outside of the sandbox environment, they're staying well within it, and they're not really doing a whole lot of harm. But it's not what people expect, it's not what people thought was coming with their software, so it's something to be aware of. Don't trust everything you install from Snap's App Store, just like you shouldn't just go and install anything and trust everything from any app store. These are people that are developing these things, and people can be nefarious. So do your due diligence, do your research, know who you're downloading your software from. So what has my experience with snaps? It's been great overall. I try and install basically any user application I can with Snap these days, and most of my software at this point is Snap packaged. So I use Slack. A lot of JetBrains software is Snap packaged. Some browsers like Firefox and Chromium are Snap packaged, and they're all updated very quickly. Even Microsoft is on the bandwagon, has kept Visual Studio Code and some other software up to date, and it's been really nice. I have not really had any issues aside from a couple bugs that were pushed out by the developers, but these things were updated quickly, and within a day I was pretty much solid with almost any issue that I had. So I've had an amazing experience so far, and I cannot wait to keep using snaps, to be honest. Overall, snap packages are my favorite packaging solution right now. I really like the idea of being able to update your operating system independent from your applications, and your applications not really mixing with each other in any shape or form. This has proven to be very good for macOS and Windows, and I think it opens up an exciting new gate for Linux users. On top of that, it enables developers to target one distribution channel and basically be able to get their software on every Linux distribution out there, which has been very difficult up until now. The wide adoption for snaps is very promising, and even though AppImage and Flatpak have done very well on the technological side of things, I think that snap packages have the best chance at giving us a universal package format for all Linux distributions. Now thank you guys for watching this one. I know it was a little bit more technical, it was a little bit more nerdy than some of my other talks, but I really appreciate you guys watching this with me. Have you guys used snap packages yet? Please let me know what you think. Let me know what your experience is. Do you have another preference for a packaging format that maybe I haven't even talked about here? Definitely let me know, because there are some other ones that I didn't talk about at all that are very interesting and fascinating in their own right. If you'd like to follow me online, please check me out on Twitter. That's ParanoidCoder. I'm here on YouTube, ParanoidCoder as well. And I also co-host a monthly podcast called Mod Chat with Mr. Mario 2011. We talk about modding consoles and various different things across all different platforms. So if my content is interesting, if you like modding consoles, or even just hearing us blabber on about that, definitely check it out. Definitely hop on the live chat. We love seeing people in there. Anyways, thanks everyone for watching another video by me. I'll have more content coming out next month, and I really appreciate it. Have a good one, and I'll see you guys next time.